Okay, let's unpack this. Picture this. A volcanic blast. So enormous, it didn't just darken the sky locally, but actually nudged the Earth's climate and carved out a lake bigger than Singapore.
Mm-hmm.
That's the story brewing from the Toba Supervolcano eruption 73,500 years ago. We're diving deep into its mind-boggling scale and the surprising ripples it sent across the planet, all based on the geological and archaeological clues you shared. Let's get right into this.
Indeed. This deep dive takes us to North Sumatra, Indonesia, the site of the Toba super eruption.
Hmm.
A truly colossal event, one of the most significant volcanic episodes in the last 2 million years.
Wow.
We're going to explore the geological history locked within this landscape, the immediate and potential long-term environmental shock waves, and the captivating debate around how it might have affected human populations, with a particular focus on what the evidence from India is telling us.
Right. And our roadmap for this exploration includes geological studies that have painstakingly pieced together Toba's eruptive past, alongside archaeological digs in India that are revealing snapshots of the environment and human life around the time of this cataclysmic event.
Exactly.
Our mission: to truly grasp the immense power of the Toba eruption, to understand its far-reaching consequences as revealed by current research, and to really dig into the compelling but perhaps not entirely accurate theory that this eruption caused a drastic human population bottleneck.
Yeah, that bottleneck idea is a big one.
We want to cut through the complexity and bring the key insights into sharp focus for you. So, to set the stage, let's visualize the landscape that this eruption left behind. Lake Toba isn't just any lake. It's the world's largest tectonic volcanic lake, born from the collapse following this super eruption.
Mm-hmm. The scale is just enormous.
It stretches for 87 kilometers, is 27 kilometers wide, and plunges over 500 meters deep in places.
Really deep.
And it sits high up, 906 meters above sea level, with the steep walls of the caldera towering another 1,200 meters above the water.
That's some dramatic scenery.
That dramatic view alone hints at the sheer force involved, doesn't it?
It really does. And what's truly remarkable is the sheer volume of material that was ejected during that eruption. Estimates range from 2,500 to 3,000 cubic kilometers of magma.
Okay, that number is hard to picture. How much is that really?
Well, to try and get a sense of that scale,
Right.
that's enough material to bury, say, the entire state of Rhode Island under a layer of ash hundreds of feet thick.
Wow. Okay, that helps.
The volcanic ash blasted into the atmosphere weighed in at around 10 to the 15 grams.
Mm-hmm.
Pyroclastic deposits, think of them as these scorching hot flows of gas and volcanic debris. They blanketed an estimated 100,000 square kilometers.
Goodness.
And lava flows even reached as far as the Malacca Strait and the Indian Ocean.
So not just ash, but actual lava flows traveled that far.
Some flows did, yeah. And incredibly, tephra, essentially fragments of volcanic rock and glass ejected during the eruption from Toba, has been found in India 3,000 kilometers away.
3,000 kilometers.
And even in the South China Sea.
It's hard to wrap your head around that kind of reach. And this is where it gets even more intriguing for understanding the long-term activity of this volcanic system. The geological record tells us that Toba wasn't a one-time event, right?
That's right. There were actually 4 distinct periods of eruption that we know of. First, the Horangul Dacite Tuff, or HDT, formed about 1.2 million years ago.
Okay.
Then came the oldest Toba Tuff, OTT, that was 0.84 million years ago.
Yeah.
Followed by the Middle Toba Tuff, MTT, 450,000 years ago.
And the big one.
And finally, the youngest Toba Tuff, or YTT, 73,500 years ago. That's the one we're primarily focused on, and by far the largest of them all.
So a history of massive eruptions, not just one.
Exactly. And if we connect these different eruptions to the bigger picture, we see a fascinating pattern emerging. The center of these eruptions actually shifted over time, moving from the north to the south of the Toba region.
Oh, interesting. Why would it move?
Scientists believe this is likely due to the movement of a shallow magma chamber beneath the surface.
Ah, okay.
What's also noteworthy is the long period of dormancy, between 350,000 and 415,000 years, that occurred before the massive YTT eruption.
That's a really long, quiet period.
It is. And the size of the magma body and the time it takes for different chemical zones, sort of layers, to develop within it, likely played a significant role in these extended dormant periods.
So bigger magma chambers need more time to cook before they blow.
Kind of, yeah. Larger magma bodies generally require more time for this internal layering, this zonation, to occur, which can influence the timing and intensity of subsequent eruptions.
Okay, so we've established this eruption was mind-bogglingly huge. Multiple indents, shifting location. Now, let's think about what happens when that much material gets blasted into the atmosphere and onto the Earth, the environmental fallout.
Right, the big question.
The idea of a volcanic winter, a period of global cooling, because sulfur aerosols high in the atmosphere increase the Earth's albedo.
Making the Earth more reflective to sunlight.
Exactly, reflecting sunlight back out. That idea has been strongly linked to the Toba eruption. Some estimates even suggest a significant drop in global temperatures for several years following the event.
Yeah, and while ice core data does indicate a decrease in global temperatures after the Toba eruption, the precise extent and duration of this cooling are still subjects of ongoing scientific debate. It's not totally clear-cut.
Okay.
What's particularly compelling, though, is examining the direct evidence in regions that were heavily affected by the ashfall, like India.
Right, 3,000 kilometers away.
Exactly. Archaeological sites in India, notably those in the Jururu River Valley, have yielded ash deposits that have been definitively linked to the YTT eruption. These sites provide us with a unique window into the immediate aftermath of this colossal event in a region far removed from its origin.
And those archaeological discoveries in India are truly remarkable, aren't they?
They really are.
In the Juro Valley, Middle Paleolithic stone tool collections have been found in layers both beneath and, crucially, above the Toba tephra.
Below and above.
So, for someone hearing this for the first time, why is this finding the tools above the ash so important?
Well, it strongly suggests that human populations were living in this region before the eruption and significantly continued to live there afterwards. They persisted through it.
They didn't just disappear or get wiped out by the ashfall locally.
Exactly. And studies of the sediments in the Jururu Valley offer crucial environmental context. They indicate that a cooling trend was actually already underway before the Toba eruption hit.
Oh, okay. So the climate was changing anyway.
Yeah, the global climate was naturally shifting towards more glacial conditions at that time. The thick ash deposits initially seemed to have favored the growth of grassland communities.
So the ash changed the local vegetation.
It seems so, at least initially. Then those grasslands gradually transitioned back to more wooded environments over time. Importantly, isotopic analysis of paleosol carbonates from this region that's looking at the specific chemical makeup of ancient soils to understand changes in the environment. It suggests that the YTT eruption did not cause a long-lasting catastrophic environmental upheaval in this part of India.
Not a total ecological disaster zone, at least not long-term.
Apparently not in that specific region, based on this evidence.
And the story gets even more compelling when we examine the human-made artifacts, the tools themselves.
Yes, the technology.
Detailed analysis of the stone tools from the Jururu Valley reveals minimal changes in how these tools were made after the eruption.
So the way they were knapping stone, the styles, pretty much stayed the same.
Exactly. This cultural continuity is a strong indicator that the same populations were present both before and after the event. It suggests they were able to adapt to any immediate ecological challenges.
Adapting rather than being replaced.
Right. There's no archaeological evidence here to suggest a complete collapse of the population or, a replacement by new groups with totally different tool makings.
Precisely. And the archaeological evidence from India demonstrating population continuity and adaptation in a region directly impacted by the ashfall casts considerable doubt on the idea of a sudden, near-extinction event for humanity caused solely by Toba.
Right. The people on the ground in India seem to tell a different story. So let's summarize the evidence that argues against a severe bottleneck caused only by Toba.
Okay.
We see a lack of evidence for a widespread die-off of mammals associated with the eruption.
Right, not just humans, but other animals too.
We observe the continuous presence of human populations and their consistent tool-making technologies in India right through the event.
The cultural continuity, yeah.
And we have indications that the global climate was already trending cooler before Toba even occurred.
The pre-existing trend.
All of this suggests that the impact on humans might have been more regionally specific and perhaps less devastating than initially proposed.
Less globally catastrophic.
And it's also crucial to remember that modern humans at that time were already developing sophisticated ways to adapt to different environmental conditions. They weren't helpless.
That's a critical point, resilience and adaptability. While the Toba eruption was undoubtedly a massive geological event with significant environmental consequences, and these likely varied from region to region.
Sure, the impact wouldn't be the same everywhere.
The current evidence from geology, archaeology, and genetics paints a much more intricate picture than a simple cause-and-effect relationship with a global human bottleneck.
It's more complex than just Toba erupted, humans almost died out.
Much more complex. The genetic bottlenecks suggested by some research may have unfolded over a longer time scale, or could have been the result of a combination of factors, not just this single volcanic event. The archaeological findings from India powerfully underscore the resilience and adaptability of human populations, even in areas that experience significant ashfall.
So, okay, while the Toba supereruption was clearly an extraordinary geological event, a truly massive eruption with significant regional impacts.
Absolutely. Can't downplay the eruption itself.
The idea that it single-handedly caused a near-extinction event for humanity just isn't strongly supported by the current evidence, especially when we look closely at the archaeological record in places like India.
The evidence leans away from that stark conclusion right now.
It really highlights the ability of early humans to weather some pretty extreme environmental shifts.
Precisely. It's a powerful reminder of the adaptability of early human populations in the face of dramatic natural events.
It's truly incredible to contemplate an eruption of this magnitude and how it might have shaped our distant past. The geological evidence paints this picture of unimaginable power, while the archaeological discoveries offer a fascinating and maybe reassuring glimpse into the resilience of past human populations when confronted with such extreme events.
Absolutely. The Toba eruption stands as a major geological event with significant environmental impacts, though these likely varied considerably across different regions. That variability is key. Right. The compelling evidence from India strongly indicates that human populations there were able to persist and adapt in the aftermath. So the connection between Toba and a global human bottleneck remains a captivating area of ongoing research and robust debate,
Still lots to figure out.
with current findings consistently pointing towards a more nuanced and complex understanding of that relationship. It wasn't a simple story.
Okay. And that brings us to our final thought for you, the listener. Considering the sheer scale of the Toba eruption and, our own modern vulnerabilities to large-scale global events, what can we learn from how past populations managed to adapt to such extreme environmental changes? How might a similar super-eruption challenge our highly interconnected global society and our complex technological infrastructure today?
It's certainly a profound question to consider, especially as we navigate our own era of significant environmental change and global interconnectedness. Food for thought.
Definitely. Thank you for taking this deep dive with us into the fascinating story of the Toba supervolcano. We encourage you to continue exploring the sources and the ongoing research into this ancient and really awe-inspiring cataclysm.